Warm welcome. You're watching Headlines today with me, Zaka Jacob. The fastest missile in India's defence armoury is indeed on fast track. Just a month after its pre-induction testing facility was in place, the Navy is now in the process of having the BRAHMOS on board. The land variant for the Army has also been approved and is in production, and in about a year's time the Sukhois may well have them on board as well. The BRAHMOS, of course, has now become the toast of the armed forces, and tonight my colleague Arunikan Sinau tells you just why.
Strategy, tactics, well, maybe, but indigenous weapons of war is not what India is known for. We have rarely shown the way to the world in the modern era of combat. But BRAHMOS, that's a different story.
The Tomahawks, blooded in the two Iraq wars, used in great numbers with pinpoint accuracy right at the beginning, breaking any semblance of resistance that the enemy might have had. The harpoon, the French exhaust set, the Chinese silkworm, all lethal weapons of a different category. They belong to an elite list of the most dreaded weapon system in the world. A weapon system in which the entire activity of tracking, chasing, recognizing and annihilating the enemy is reduced to the press of a button. The rest is done by the cruise missile. For reasons of stealth and accuracy, all these cruise missiles are subsonic. And then came BRAHMOS. Bra from the mighty Indian river Brahmaputra and Mos from the serene Moskova river. The partnership was clear. The Russians would provide the technology and semantics aside, India would foot the bills.
In our missile we used ramjet, supersonic ramjet. It's unique technology that have only Russia. Russia spent a lot of time and money for developing such kind of engine, such kind of technology. And we decided to use this high-level technology in our missile.
The result? A cruise missile 3 times faster and 9 times more lethal than any outside Russia, at a top speed of 2.8 Mach. The dreaded Tomahawks have a max speed of 0.8 Mach. The BRAHMOS's closest rival is the SSN-25 Sunburn, Russian-Chinese joint venture with a top speed of 2.2 Mach. And with its stealth capabilities, a minimum signal emission and the unique ramjet engine, BRAHMOS provides a reaction time of a mere 2 seconds to its enemy. The BRAHMOS can access the American GPS or the Russian GLONASS series of satellites to navigate. For that matter, the European Galileo as well, when it comes into existence by the turn of the year. But not at sea, where there are no mountains or high-rise buildings to deal with, and therefore it can fly in a straight path. Now, on a short flight or towards the end of its cruise, the BRAHMOS can skim the oceans barely 10 meters from the surface, invisible to the line of sight radars.
As low as possible is to avoid any identification by the enemy. But if the distance is more, we can afford to fly high because the initial part of the trajectory is not tracked by the enemy system. So we fly high. When you fly high, you can go for higher speed with minimum fuel consumption. So you get a better range.
And it is this invisibility which has brought it to the center of the world's attention. The Western world is yet to master the ramjet technology, the key to the BRAHMOS, and even before it has fully realized, the BRAHMOS has a fan following like Singapore, Israel and Vietnam. In fact, after initial interest, some countries like Chile and South Africa are reconsidering the entire idea of wanting to procure it due to the sheer ferocity of the BRAHMOS. Understandably so, as the balance of power would be lopsided in their favor and could trigger an arms race.
It is practically impossible to detect it. There are no foolproof countermeasures against it. And once it's launched, you cannot escape it. Clearly a deadly combination. So then what goes into the making of a cruise missile? Take a look.
Agni, India's intercontinental ballistic missile project. The crucial Agni 3 was tested with partial success about a month ago. It's a project which India cannot let fail. It is India's ticket to targets at 3,500 kilometers and beyond. So what's the difference between the ICBM like Agni and a cruise missile like the BRAHMOS? Well, technicalities apart, an ICBM's trajectory crosses the Earth's atmosphere while the cruise missile stays well within. Based on inputs from the various intelligence gathering agencies, it could be a satellite, a UAV or the good old James Bond type spy. The fire control system feeds the direction and description of the target into the onboard computers of the BRAHMOS. And then the only manual activity is the pressing of the launch button. This is the point of no return.
Missile system takes off from the canister, pushed by the thrusters. We have got the gas generators inside the canister. They generate the gas which makes the missile to be pushed up. When they pushed up, the wings and fins are deployed.
The missile is pressured out of the canister to a height of up to 240 meters. Even if fired from a submarine 40 meters below the surface, it will rise to 60 meters above it.
So fired through the gas generator and thrust booster, it comes out of the water. So the travel is going to be a free travel using the underwater booster.
Okay.
And once it comes out of the water level, when it comes out, then the air booster is burns, the main booster, and the missile is
There'll be two
deflected to
boosters.
this.
The inertial navigation system, which guides and gives correction to the missile during its mid-flight, takes over the navigation. For power, the boosters are ignited and within a couple of seconds accelerate the missile to the speed of Mach 2.
Once it has reached a height of 250 meters, then it is a time to turn it to the direction of the target.
This is
So target is done by the thrusters which are positioned in the nose cap, and it turns the missile. Once the missile is turned, the function of the nose cap being over, it is ejected out by the pyros. Once the nose is ejected out, this has got an opening for the air intake.
Now the air intake exerts the exact amount of pressure on the booster to make it fall off. That's when the ramjet engine takes over.
Now the air which flows into the combustion chamber, and now we are increasing the speed, lifting up to 2.8, and it is in supersonic cruise. So this is we call a cruise phase, where the speed is constant, altitude is constant, and the attitude of the missile is constant.
Now once the missile is in close proximity of its target, the sly radar called the seeker opens up. The inertial navigation system has done its job and shuts down. The seeker is sly because it makes the BRAHMOS dive down to the 10 meter above surface height and then opens up for barely a fraction of a second. And before you can say Jack Robinson, it has shut up so that no radar is able to pick up its location. But within that fraction of a second, it has sent out a signal good enough to check exactly where its target is.
When it goes closer, you need to home on.
Okay.
So to home on, we have got the homing seeker, which makes the missile to target to the exact targets.
By the time the BRAHMOS reaches within 10 to 12 kilometers of its target, it is too late for any countermeasure in the world to react. So might as well be dead sure. The seeker radar opens up permanently. The result?
Well, it's time for a breather now, but on the other side of the break, we take you into the depths of the ocean and show you how the BRAHMOS would be launched from a submarine, and then take you up in the air to show you how the BRAHMOS would do its dance of death from the belly of a Sukhoi. Power is how you use it. India has the BRAHMOS, decidedly one of the deadliest cruise missiles in the world. But how do we use it? Because the effective use of a cruise missile can decide the fate of a war, not just in days or hours, but in minutes.
Certainly the defining snapshot of the Second Iraq War, but what won the war was this: a concentrated pinpoint attack of numerous cruise missiles of various range and capabilities right at the beginning of the war.
first missile to be launched, it takes about 4 minutes to set it up, and between the first and the second, the difference is 2.5 seconds.
Okay.
If you deploy it on a large scale in this beginning of a war, you can put it as a total network, and you can launch as many as hundreds of missiles together from the land, which gives a major impact on the first day of the war itself.
Okay.
The way the Tomahawk was used. The difference here, of course, is the accuracy and the tremendous power that BRAHMOS has got.
Destruction of the army's arsenal, taking out the military commanders, driving the political leadership underground, and pulverizing the entire supplies. All this not in days or hours, but in a matter of minutes, with no collateral damage to civilians. It was a lesson learnt by the Americans from the first Iraq war, where the Tomahawks were used, but not as effectively. The philosophy of the use of cruise missiles became clearer during cruise attacks in Bosnia from fighter jets, which actually ended the conflict. The strength of a cruise missile lies in its strategic use, meaning it has to be a sea-land and airworthy missile, an answer on ground, mobile autonomous launchers.
It is totally self-contained. It has got 3 launchers from where you can launch 3 missiles, and it has got its own power supply, its own fire control system and communication system. So a single vehicle with 3 launchers can be used to launch 3 missiles based on the target parameters which it receives from the command post. But it is in a network configuration where 4 such vehicles are networked together.
That means 12 BRAHMOS.
12 BRAHMOS controlled by a mobile command post, which is also a Tatra 8x8 vehicle, which in turn...
there are how many people are required? Just about?
It requires 2 operators to...
The Navy has already announced BRAHMOS as a standard fitment on all its destroyers and cruisers. In fact, Project 15A, India's indigenous destroyer, will have 16 of them.
All future ships will have BRAHMOS because the Navy has found it very cost effective, and not only that, they have seen flights. We have done 10 flights for the Indian Navy, and we have shown 100% results in all the 10 flights.
So the future ships would mean the future Talwar class, there are 3 of those which are coming in. Would they be, how many BRAHMOS missiles would they be fitted with?
The Talwar class, there are 3 follow-on ships, and each ship will have 8 BRAHMOS missiles. Destroyer, which is called 15 Alpha. It has got 16 missiles.
And all in a vertical?
All in vertical configuration.
The land and sea versions are ready and tested. What is the biggest challenge ahead is fitting the BRAHMOS on a Sukhoi without canisters or gas generators, and of course a lightweight booster, bringing the weight of the air version to 2.5 tons, nearly half a ton lighter. The first trial is slated for 2007 end.
You see a different nose cap because there is no deflection involved. It's only just a cover for the air intake.
Very good.
And we need stabilization because when we drop the missile, it needs stabilization. So we have got additional fins attached at the end.
Okay.
So how it is operated is just we drop the missile from the aircraft. When it comes down by a few meters down, the main booster itself straight away starts, kicks to Mach 2, and then the sustainer takes over.
At the BRAHMOS complex, we were given to believe that by 2010, the BRAHMOS dream would be fulfilled. And like the oath of a true soldier, it would be able to serve wherever it's ordered to. Land, sea or air.
So you think India has spent millions on an equipment of war, right? Well, it's not as much about using it as it is about making money out of it. India might have spent millions, but it intends raking in the billions.
The poster boy of India's military prowess, a strategic missile with the ability of turning victory into defeat for the enemy. Right, so you might expect BRAHMOS to be a hush-hush affair. On the contrary though, as soon as its versions are ready, it will be up for grabs for anybody willing to shell out the moolah.
When we start our development, we agreed that our missile, BRAHMOS missile, should be development for export, not only for both country, but for export. That's why we agreed that we developed our missile inside of frame MTSR.
As of now, the cost of the 6-meter rather massive missile will roughly be between 5 and 10 crore. This price is many times cheaper than anything available in the market, and the joint venturers could easily hike the price by a good 20% without losing a single client. What's even better is that the fuel it uses is not only liquid and therefore storable, but also cheaper and lighter than the solid rocket fuels.
We have to make the airframe, we have to make the launchers, fire control systems, and then we have to integrate with the vehicles, ships, parts of the ships. All we have to build. When it came to our consideration, we thought the private industries are more equipped to do those tasks. So we identified some 4 major private industries for undertaking our hardware.
There are already nearly half a dozen countries queuing up. Clearly, business seems good. But the BRAHMOS is regarded as the end of the difference between cruise missiles and the intercontinental ballistic missiles. Australia, America and Russia are a few of the countries working on the scramjet technology, which will make it possible to travel at a speed 30 times the speed of sound on liquid fuel. The difference between a cruise and intercontinental ballistic missile will vanish, and missiles will enter and exit the atmosphere at will. Already the scramjet technology is nearing a breakthrough in cheap space travel and moon missions. Ironically enough, BRAHMOS might be among the first of its kind, but could well be a bygone story within a decade. But till then, it shall remain the neighbor's envy and an owner's pride.
Well, the power of the supersonic cruise missile, the BRAHMOS. But just how deadly is this missile vis-a-vis the traditional ballistic missile, and will it help India break into the global cruise missile market? These are big questions that need to be answered. We'll try and get an answer to many of these questions from Sandeep Unithan. He's an assistant editor with the India Today magazine. But that'll be in just a moment. A break first. When we come back, Cruise Control will be back. We're discussing the power and the might of the BRAHMOS, arguably one of its own kind in that sense in the cruise missile market. Let's try and put these questions to Sandeep Unithan, assistant editor from the India Today magazine. First of all, just how much forward does the BRAHMOS take India's missile program?
Well, Zaka, you got to look at it from the viewpoint of India's indigenous defense hardware. We've never really had a product that has actually managed to break into the world market, and here you have a missile which is like no other in the world, and which is like probably the finest cruise missile in the world, and we have for the first time we have a chance of grabbing a slice of a very substantial portion of the world missile market.
All right, so it's got great potential, but let's just go back to some of the basics of this BRAHMOS missile, and one of which is the propulsion systems that it uses. Basically, it depends on 2 propulsions. One is the solid propellant, which I believe is the first stage, and the second one is this ramjet technology. I mean, talk us through this ramjet technology. What's the novelty value? Why is it so unique?
Well, because it's like the Russians, more than anyone else, during the years of the Cold War, they invested considerable resources and time and efforts into developing a missile that could destroy NATO aircraft carrier battle groups, which was their biggest threat, right? They would have to face these masses of aircraft and aircraft carrier battle groups attacking the Russian homeland. So they needed missiles which were large enough, which could go and attack all these ships and sink all of them with a very high probability. So they, like I said, they invested considerable resources into this, and one way that they headed for was into ramjet technology, because that could actually power missiles to faster than 3 or 4 Mach. And they've actually been the leaders in the world. I mean, there's nobody in the world today who's, they've actually gone into the BRAHMOS is actually a generation 2 supersonic missile. They've actually developed a first generation and then gone on to perfect that with the BRAHMOS. They had what's called the Sunburn, which is sold to the Chinese Navy, and now they've taken it further with the BRAHMOS or the Yakhund as it was called in Russia.
In terms of the range that this missile possesses, it's not really the longest range in the world cruise missile market.
That's because of the NTCR. See, I mean, a lot of this technology, you must remember, comes from Russia, and the missile technology control regime prohibits the selling of missiles, anything beyond 300. So they have to actually sell something that's below 300. So they very wisely called it a 290 kilometer missile.
And how important is it that the fact that you can launch the BRAHMOS from multiple launch systems? You can launch it from a submarine, you can launch it from a ship, you can launch it from the ground as well. I mean, how easier does that make the whole business of mass production of the BRAHMOS?
So it standardizes production. I mean, like you said, I mean, it's just like you have one missile with all you change is you just have slight changes in the seeker package, and you have one standard missile. You just change the seeker, you just tinker around with it a little bit. But otherwise, it's essentially 90% of the missile is going to remain the same, and that saves you a lot of costs. And this is what's called a universal cruise missile, right? I mean, this is probably one of the very few missiles in the world which can be launched from probably 4 dimensions.
All right, and final word of that, and again, I guess we go back to the reference point that we started off with. Will the BRAHMOS, in that sense, help India break into the world cruise missile market, as it were, because it's currently dominated by the Americans, the French, and what have you?
Right. Actually, I think the BRAHMOS does have a very fair chance of breaking into the world market, because the world missile market, if you look at it today, is dominated. It's basically a question between the fast hares and the slow tortoises. Right. The Americans have been kind of banking on the slow tortoise logic, the Tomahawk and the Harpoon. These are missiles that are actually subsonic missiles. So they say that, okay, the missile moves slower, but it's much more intelligent. And here you have us with a BRAHMOS, which is like the speed of a rifle bullet, right? I mean, that's like probably faster than anything. That is the speed of the fastest aircraft in the world.
Absolutely. 2.9 times the speed of sound, I guess, does have potential, doesn't it? Thanks very much, Sandeep Punithan, for joining us and giving us your perspective on the BRAHMOS and just where this missile has the potential to take India in terms of the global cruise missile market. That, I'm afraid, is a wrap of Headlines Today special for tonight. Thanks for watching. We'll see you again tomorrow night, same time for the